Hello everyone, and welcome to today's lecture. In this session, we are going to explore one of the most beautiful and classical identities in trigonometry, the product of sine from 1 degree to 89 degrees. This is a problem that looked intimidating at first, but as you will see it unravel in an elegant and satisfying way. So let's get started. Our problem today is straightforward. To state but rich in mathematical beauty, we want to find value of the product. Sine 1 multiply sine 2 multiply sine 3, so what multiply 89. This is, we are multiplying together the sine of every integer degree from 1 to 89. Now pause for a moment and think. We are multiplying 89 numbers, each of which is between 0 and 1. So we expect the result to be very small, but we can find an exact closed form. That's our goal. The challenge is to express this product in a clean and simplified form, not just a decimal approximation. So we are looking for something like a fraction involving a square root and power of 2. Okay, this is a classic problem in trigonometry, and it connects beautifully with some deep idea about roots of unique and polynomial equation. So the key observation, we need P equal to product of k from 1 to 89 sine k. The key insight is that the identity in the trigonometry, the sine 90 minus theta minus theta is equal to cosine theta. So term pay approximately sine 80 degrees equal to cosine 1 degree, sine 88 equal to cosine 2 degree, and so on, and sine 46 equal to cosine 44. Although we know that sine 45 equal to the square root of 2 divided by 2. And finally, we can write the p. We can write p is equal to sine 1 multiply sine 89 multiply sine 2 multiply sine 88, and so on, sine 44 multiply sine 46 and multiply sine 45. The group each to degree to get to together. Using sine 98 minus theta is equal to cosine theta. We know that the sine 89 is equal to cosine 1. Sine 88 is equal to cosine 2. So we can rewrite the p as sine 1 multiply cosine 1, sine 2 multiply cosine 2, and so on, sine 44 multiply cosine 44. Whole multiply is square root of 2 divided by 2. Also, we know this identity sine theta cosine theta is equal to 1 divided by 2 sine 2 theta. So we can rewrite the p as 1 divided by 2 sine 2, 1 divided by 2 sine 4, so on 1 divided by 2 sine 88, and multiply square root of 2 divided by 2. So we can write, if we write this relation in closed form, we can write the p is equal to 1 divided by 2 power 44, multiply square root of 2 divided by 2, and product of sine to k from 1 to 44. So we have also p equal to 1 divided by 2 power 44, multiply the square root of 2 divided by 2, product of sine to k from 1 to 44. But we should note that product of sine to k from 1 to 44 is equal to sine 2 multiply sine 4 multiply and so on, and multiply sine 88. Also, we have another identity, that product of sine kp divided by nk from 1 to n minus 1 is equal to n divided by 2 power n minus 1 for n equal to 180. So it's time by k from product of sine kp divided by 180, k from 1 to 179 is equal to 180 divided by 2 power 179. Using identity, we can write the product of sine kp divided by 180, k from 1 to 179 is equal to 180 divided by 2 power 179. Also, we know that the sine 180 minus theta is equal to sine n theta. And we can write the product of sine kp divided by 180, k from 1 to 89, multiply t from 91 to product of sine kp divided by 180, k from 91 to 179, multiply sine 90 is equal to 180 divided by 2 power 179. We can rewrite the product of t sine kp divided by 180, k from 1 to 89, multiply product of sine jp divided by 180, j from 1 to 89 is equal to 180 divided by 2 power 179. Actually, the second term in this relation has been replaced with this term. We can rewrite the expression as product of sine kp divided by 180, k from 1 to 89, power 2 is equal to 180 divided by 2 power 179. So we can write that the product of sine kp divided by the 180, k from 1 to 89 is equal to the square root of 180 divided by 2 power 179 divided by 2. So we can write that P is equal to product of k from 1 to 89 sine kp divided by 180 is equal to square root of 180 divided by 2 power 179 divided by 2. We can know also the square root of 180 is equal to square root of 36 multiplied 5 equal to 6 square root of 5. So also we know that 2 power 179 divided by 2 is equal to 2 power 89 multiplied 2 power 1 divided by 2 is equal to 2 power 89 multiply square root of 2. So we can rewrite that the P, the product of the sine 1 to sine 89 is equal to 6 square root of 5 divided by 2 power 89 multiply square root of 2 is equal to 6 square root of 10 divided by 2 power 90. So finally, we can tell that the P is equal to 3 multiply square root of 10 divided by 2 power 89. This is the closed form of your product. And final answer that we can tell that sine 1 degree multiplies sine 2 degree multiplies sine 3 degree and so on multiplies sine 89 degree using this identity is equal to 3 square root of 10 divided by 2 power 89. And you can see the final answer in the lower side of the page, that sine 1 degree multiply sine 2 degree multiply sine 89 degrees is equal to 3 square root of 10 divided by 2 power 89. Also, we can calculate the numerical value of these results. 3 square root of 10 divided by 2 power 89 is equal to, we know, you can see that the 2 power 89 approximate equal to 6.1897 multiplied 10 power 26. And although we know that 3 square root of 10 is equal to 9.4868, so the product is approximate equal to 9.4868 divided by 6.1897 multiplied 10 power 26 is approximate equal to 1.5326 multiplied 10 power minus 26. The product of 89 numbers, each between 0 and 1, should be really small. And is approximate equal to 1.53 multiply 10 power minus 26. You can see the product is extremely small as we expected. Thanks for watching. See you in next video.